Good morning, everyone. Thank you for joining us for this webinar. Today we're going to be going over a topic that's important to everybody, and that's how can you increase productivity in your manufacturing environment. And we're going to talk about how you can use overall equipment effectiveness, or OEE, to help you improve that manufacturing productivity. So thank you everyone for joining us. We hope everyone's doing well and staying safe kind of in these crazy times. But being able to improve your productivity is always important, but especially right now, I know in the U.S., we're seeing some companies that are getting a sudden increase in demand by 400 or 500%. So they've got to figure out a way to increase their productivity very quickly. They got to figure out what can we do to get more units out the door. So that's what we're going to talk about today, is how you can use OEE to help you increase that productivity and to help you see where you need to make improvements and things like that to get more units out the door. All right, so here's what we're going to be going over today. So first we'll start off kind of by going over your panelists, do a little housekeeping, then we'll get into why is OEE important? So why are you here? What's the importance of you sitting in on this 45-minute webinar? What are we going to go over? Then we'll talk about how OEE and TEP, which is another important metric that goes along with OEE, how those two are calculated, the different factors that go into that. Then we'll talk about those OEE and TEP contributing factors, the importance of those, what you need to look out for. And then at the end, we'll talk about why should you use 42Q for OEE and TEP. So what advantage do you have of using our product for measuring these important metrics? So we'll go through that. All right, so your panelists. So I am Bobby Hanna. I'm your moderator and host. So I'm a senior technical trainer here at 42Q. I've been working as a software trainer for over 10 years. I was a technician before that. So my experience mainly is in planning, developing, and delivering training programs. So I create and kind of plan out all the training programs here within 42Q, the product training. So, you'll be hearing my voice a lot when it comes to these webinars and training courses and things like that. And then we've also got Jim Morgan, who's our other panelist. So he's one of our sales engineers here at 42Q, and he's got over 20 years experience in high-tech manufacturing. And right now, for us, he's currently responsible for the IoT and machine connectivity. So I'll kind of go over the front end and be talking to you guys about what OEE is, and then I'm going to hand it over to Jim, and he's going to talk to you guys about the benefit you're going to get out of using this in 42Q and our different features and capabilities aligned around that. All right, so if you have any questions or comments during the webinar, inside the Zoom meeting down at the bottom, you'll see your little control bar. If you click on the chat icon, the chat window will pop up. As the webinar is going on, feel free to enter any questions or comments that you have into this chat. And then at the end of the webinar, we're going to go through and handle all questions and comments. So we'll start with any ones that have been put into the chat. So we'll start at the top and kind of go through. Depending on how many of those we have, at the end of that, we'll give everyone a chance to unmute your line and ask any additional questions that you have at that time. If it gets to where we have too many questions, we'll kind of take them offline and answer them and put them all into a document or something like that. So, but any questions or comments that you have, just know that we will get them answered. If we don't have time today during this webinar, we will definitely get you an answer and get it sent out to you in there. All right, so why is OEE important? So when it comes to your productivity for your machinery, so again, the ultimate goal is to get as many units out the door as possible, as many good units. So you need to look at what can I do to increase the number of units that I'm getting out the door, increase my productivity. So there's three main factors that identify how well you're doing with your productivity. And that's availability, so how much your equipment is up and ready to be used, your performance, how many units you're getting out the door, or how many units you're getting produced, and then quality of how many good units you're producing. So each one of these three factors is important in its own right when it comes to productivity, but each one of these individually does not give you the full picture of how productive you are. Just because your equipment's available doesn't mean that it's being used. Just because you're getting units through the machine doesn't mean that they're good units. So what you need is a single metric that's going to kind of give you an overall picture of how productive you are. So that's where overall equipment effectiveness, or OEE, comes into play. So OEE is going to use all three of these factors, and it's going to give you a single metric percentage that you're going to be able to look at and say, I'm good or I'm not good. By looking at that percentage, you'll know what you're reading. You can just glance at it real quick and know, okay, I'm good to go, or there must be some kind of issue, and then I can look at it further and start looking at these three factors individually and figure out where my issue's at, and then based on wherever the issue's at in those three factors, you'll know what to look at as how to improve that or fix that issue. And then we'll take a look at that as well in here. So we're going to take a look at all three of these factors individually. But before we get into that, let's take a look at how OEE and TEP are actually calculated. So to calculate your overall equipment effectiveness, you're going to take that availability percentage and you're going to multiply that by your performance percentage and then multiply that by your quality percentage. And so this is going to give you that single metric that's going to let you know your productivity percentage at your current operating schedule. So if you're running 2 shifts a day, 5 days a week, something like that, this is going to let you know at your current operating schedule how you're running. And again, this is going to give you that single metric that you can look at in a dashboard on the screen somewhere. And you'll know just by glancing at that if everything's going good or not. And then, like I said, if that number starts to drop or it's not where you want it to be, then you can start looking at these three individual factors and figure out where the issues are. Now, along with OEE, so again, OEE is going to give you your percentage at your current operating schedule. Now, there's another metric that goes along with OEE, which is TEP, which is total effective equipment performance. So this is going to take a look at, it's going to give you a metric of how much potential unlock capacity you have. So this is going to take those same three factors of availability, performance, and quality as OEE, but it's also going to look at utilization. So utilization has to do with your current operating schedule versus all time. So versus 24/7, 365. So this is going to let you know, do we have room to grow? Do we have potential unlock capacity where if we need to start getting more units out the door, and let's say we've already got a good OEE number, so our equipment's running well, we've got a good availability, performance, and quality, we've got a good OEE, our TEP is going to let us know, do we still have room that we can grow? So like I said, maybe if you're only running 2 shifts a day, 5 days a week, maybe adding an additional day onto your schedule or adding an additional shift. This will let you know how much more room you have to grow and increase that in there. So we're going to take a look at all these factors and the calculations and things like that. All right, so our first factor here is availability. So again, your availability is going to be how much your equipment is up and it's prepared, everything's good to go and ready for units to be produced in there. So let's take a look at a little example here. So let's say an 8-hour shift, which is 480 minutes. And let's say in that 8-hour shift, we have a 30-minute scheduled break. And then we also have 30 minutes of unplanned downtime in that. So our two things that we're going to need to figure out to calculate our availability is our operating time and our scheduled time. All right, so to get our scheduled time, we're going to take the entire shift time of that 480 minutes, and then we're going to subtract any planned downtime. So this could be breaks, it could be planned maintenance, anything like that. Any planned downtime, you're going to take away from your scheduled time. All right, so to get our scheduled time for this example here, we would take that 480 minutes for the shift time and then subtract our 30-minute scheduled break. And that's going to give us our scheduled time of 450 minutes. All right, so to get our operating time, we're going to take our entire shift time and we're going to subtract any planned downtime and also any unplanned downtime. So to get in our example here, we would take our 480 minutes entire shift time, and then we would subtract our 30 minutes of planned downtime and our 30 minutes of unplanned downtime. So that's going to give us 420 minutes of operating time. So to calculate your availability percentage, you would take your operating time and divide that by your scheduled time. So in our example here, that would be 420 minutes divided by 450 minutes. So that's going to give us a 93.3% availability, which is pretty good. All right, so that's how you calculate your availability. But again, all these factors are important, but they individually do not give you the full picture, because again, we have 93.3% availability. That means the equipment was up and running 93.3% of our schedule time. We don't know, was there an operator there so the units could actually be made? Were the units good? We don't know any of that just by looking at the availability. So now we'll take a look at our next factor. So our next factor is performance. So performance is going to be our throughput. So how many units are we getting produced in this machinery? All right, so along this same example, so let's say we have that 420 minutes of operating time. And in that 420 minutes of operating time, we produced 400 units. Now, so let's say for this machinery, our optimal cycle time, and we're going to take a look at a nice round number here just to make this, this example easy. So we'll say that our optimal cycle time is 1 unit per minute. So we should be producing 1 unit per minute in this. So we need to figure out our time to produce units. So that would be these 400 units that we produced, and we said our optimal cycle time is 1 minute per unit. So that's going to give us 400 minutes time to produce units. Now, again, it's not usually this nice round number, but we're just going to make it easy for this example. So to get our performance number, we're going to take our time to produce units and we're going to divide that by our operating time. So in this example, we would have that 400 minutes for our time to produce units, divide that by our 420 minutes of operating time, and that's going to give us a 95.2% performance rating. So again, pretty good number here. But again, performance takes into account how many units you're getting produced. It does not take into account how many of those are actually good units. So we could have a 95.2% performance rate, but of those, 75 could be scrapped. So next thing we're going to take a look at is quality. So quality is going to be how many good units we're getting out of all the units we produce. So in that same 8-hour shift, we're going to say that those 400 units that we produced, 20 of those were defective. So we're going to say, out of that 400 units, 20 were defective. So that's going to give us 380 good units that we got out of that shift. So to get our quality metric, or our quality factor, we're going to take the good units and we're going to divide that by the total units produced. So in this case, our 380 good units divided by our 400 total units, and that's going to give us a 95% quality rate. Again, another good number. So those are our 3 different factors that are going to go into OEE. So now we'll take a look at calculating this. So if we look at the top here, so our availability of 93.3%, if we multiply that by our performance of 95.2%, and then multiply that by our quality of 95%, that's going to give us an OEE of 84.3. So 84.3 is a very good OEE. The world-class, your top numbers that you're going to see for OEE are around 85%. So everything's running very well. Typically, what you're going to see is 60% OEE. That's what typical manufacturing facilities are running at. So that still has, some room to grow if you're at 60%. If you're getting up around that 85%, you know that everything's running well in your organization. So, when you first start taking a look at this, or when you start to see these numbers drop for your OEE, you need to figure out, okay, where can I make improvements, or what do I need to look at as far as issues to get these numbers back up or to fix whatever the issue is. So generally for your machine productivity, there's going to be 6 big losses that you're going to see. These are the areas that you need to look at to improve your productivity. And by breaking it out, when you look at these different factors, this is going to kind of give you an indication of where you need to look to fix those issues. So these are kind of divided up under the different factors. So our first one, under availability, the big losses that you're going to see first is setup and adjustment. So this is going to be caused by your equipment adjustments and your changeovers. That's going to cause you some losses of your availability, the downtime that you're going to need for that. And then also the other big loss is equipment failure. So this could be tooling failure, breakdown, unplanned maintenance, waiting for parts, any of that kind of stuff. So those are, if you're seeing issues with your availability number, if that percentage is dropping, these are going to be the areas that you need to look at first to get that number back up. These are going to be your big losses for availability. Under performance, the first one is idling and miter stops. So this can be caused by misfeeds, material jams, obstructed product flow, incorrect settings, or blocked sensors. You're going to see with that. So next under performance is reduced speed. So this could be from dirty, worn out equipment, poor lubrication, poor environmental conditions, substandard materials, or operator inexperience. So if you're starting to see a drop in your performance factor, your performance percentage, these are the areas that you can look at these big losses to try and fix that number and get it back up into an optimal level. And then last is quality. So our first big loss for quality is process defects. So this could be from incorrect equipment settings, operator error, expired materials, especially when it comes to pharma. And then next is reduced yield. So this could be from suboptimal changeovers, incorrect settings for new parts, or equipment that requires a warm-up cycle. So again, by looking at this OEE number and these factors, when you're taking a look at that broken down, you can see, again, when you start to see a drop in the specific numbers for these factors, this is going to give you an indication of where you can look at to try and get those numbers back up and increase your productivity in there. So this is taking a look at OEE and our three main factors for that. But again, when we're looking at TEP, our other factor is utilization. All right. So utilization is going to take into account your current operating schedule versus all time, or 24/7, 365. All right, so for our same example here, let's say we have 420 minutes of operating time per shift that we have, and we're running 2 shifts a day, 5 days a week. All right, so our weekly operating time is going to be that 420 minutes, 2 shifts a day, 5 days a week. So it's going to give us 4,200 minutes of weekly operating time. Now, if we calculate all time for the week, so 1,440 minutes a day for 7 days, that's going to give us 10,080 minutes for the entire week. So to figure out our utilization, we're going to take our operating time and we're going to divide that by all time. So in our example here, we would get 41.6%. We would get that 4,200 minutes of operating time for the week divided by our 10,080. So that's going to give us 41.6% of all that time that we're actually utilizing in there. And so this utilization number is going to take into consideration when we're looking at TEP. So if we take a look at those same numbers that we got for availability, performance, and quality when it came to OEE, and we add in that utilization percentage, that gives us a TEP of 35%. So that means that 65% is unused and untapped that we have. So it lets us know that we've still got a long way to grow in this. So that's what TEP is intended for. Again, OEE is going to let you know how well are you doing right now at your current operating schedule. So TEP is it's used to indicate your hidden factory or the amount of unlocked capacity at your facility. Now, one of the things that TEP is really good for is it's a great metric for planning. Because if you want to increase productivity, one of the things you can look at is if you've got a low TEP number, that's going to indicate that there are most likely alternatives to purchasing new equipment. So most likely that means that if you're wanting to get that productivity number up, you can add another shift, add another day of the week, or maybe you just need to improve on your current OEE number. So you need to improve on that availability, performance, and quality and get that number up. Whereas if you have a high TEP number, that means that, your OEE numbers are already good. That means that availability, performance, and quality is already good. And then most likely you're already running 3 shifts a day, 7 days a week if you've got a high TEP number. So if you've got a high TEP number, that indicates that most likely you're going to probably need to add some new equipment if you want to get your productivity numbers up. Because, if that TEP number is high, that means you're getting the most out of the equipment that you currently have. So you might need to add in some new equipment to get more units out the door. So that's one of the advantages of using TEP and looking at that TEP number. All right, so Now we're going to get into, we talked a little bit about the different factors, what OEE and TEP are. So now I'm going to hand it over to Jim, and he's going to go through and talk about why should you use 42Q for OEE and TEP. So Jim, I'll let you take it away.
Thanks, Bobby. Yeah, well, as you mentioned, OEE is a metric that allows us to measure asset availability, performance, and quality. This is a measure of actual runtime processing versus what the expected values are or the accepted performance for each part built on each asset. The advantage 42Q has is they provide a wealth of OEE tools that completes the spectrum. There's a central location for data collection, for your throughputs, yields, machine up and down times, and any root causes for those downtimes. There's also machine connectivity for automated data collection. There's reports, dashboards, floor views, email alerts, and we'll get on all of those things in as we continue this discussion. They even have a fully featured CNOMS module to round out the tool set, but that's a rather long topic for another day. So 42Q's OEE offering gives your business an at-a-glance view of real-time OEE and TEP data and enable you to be proactive by spotting your less than optimal measures or trends and then taking actions to correct those problems and thereby improving your overall efficiency of the assets. So let's go ahead and roll into a use case and see how OEE can be used. Let's say we've made a new product we're going to sell. We're going to sell a thermos. And to make this thermos, there are 4 assets involved. There's a sheet metal cutter, a metal forming machine, a labeling machine for your company logo, and an optical inspection machine for testing the quality of the product that's coming out the end of the line. For simplicity's sake, we're going to say these 4 machines are commuting automatically with the 42Q. So we've designed this product, and then an engineer needs to go out and determine how long it's going to take on each one of these processes to complete the part at the process for that on that machine. So we'll say that to make it easy, each asset on each of these, each part built on each asset in this example can be measured at 1 unit per 10 seconds. This is our ideal performance. And we expect machines to be available 8 hours a day, and of course we would like 100% quality. So by setting these ideal measures, we can observe the OEE charts in real time. So let's say the first couple times we try to build 100 units from a single roll of steel. We notice that the last one coming out of the forming machine is wrinkled and needs to be scrapped. This means we're getting our ideal quality time is going to be 99%. Now we can either live with that and say, okay, that's fine. One is just going to go off the end and be terrible. Or better yet, we can, by observing this metric up front, we can discard that last piece of the roll before it goes through the cutter, and thereby saving machine time across the line. Another scenario could be, say, after 6 days of building this thermos, we've noticed that the performance of the labeling machine is dropping into the yellow zone. It's now running at, say, 1 unit per 13 seconds. First thing I would do is send a technician out to see if there's a mechanical problem, like maybe a loosened belt or a slipping conveyor belt. Or if possible, it could be an operator. Believe it or not, I've actually seen where an operator felt like he didn't have enough work to do in 8 hours, so he slowed the machine down. Yeah, he didn't realize that what he was doing could be spotted on some of the dashboards and reports. So let's go ahead and take a look at some of those reports. 42Q has by default a set of industry standard reports. There's downtime trends, root causes, dashboards, MTBF and MTTR, and some others. And these reports can be filtered in a variety of ways. A couple of my favorites are seeing an entire production line at a glance, and then drilling down into individual assets. Another one is seeing all assets of a certain type. Say we've got 5 different optical scanners, and they're all certain in our asset type group of optical scanners. We can see how each of those are performing against each other. See if there's any problems that we might have to go look at on one of those machines. In addition to default reports, with 42Q, you can write custom reports. They can be viewed or even emailed. We see this done all the time. Production managers and even planners, they like to have some of those reports first thing in the morning. Another popular option is to use one of our APIs to extract the data you need, and you can import those into your own BI tools such as Tableau, Power BI, MicroStrategy, or many of the others. Let's go ahead and take a look at the OEE dashboard. The OEE dashboard displays a speedometer style gauge for each of the OEE and TEP calculations. It also breaks out the individual availability, performance, and quality metrics and summarized by department line or location. The needle will point to the current OEE percent, and you define what those target values are to give you what's the critical red area or the yellow cautionary area, or performing as expected in the green area. And that's a metric that you define in a target value table. The center of the gauge, where it tells you that it shows the percentage there, that's actually a drill down to show you corresponding downtime problem analysis and root causes. There's a couple pie charts that you can look at. The pie slices can also be further drilled down into to show you all the data that is represented in those charts for further analysis. Let's go ahead and take a look at the downtime trend analysis report. The downtime trend analysis report shows all the reasons an asset has been down. In this particular report, we can see that there's a black line that's indicating there's a technical machine error. And it looks reasonable at first, and then about midway through the chart, it's getting a little concerning. You see some spikes there in the middle. That's a good indication that your machine should be looked at before it goes down completely. Again, being proactive. This is one of those hidden cost savings, because you can prevent an asset from going down and thereby causing a very expensive production shutdown. Next up, we have an OEE trend chart. This trend chart shows OEE, TEP, and then breaks out the individual availability, performance, and quality. In this chart, we can see the production started up during the week of April 15th and ran somewhat smoothly at about 83% until the week of July 4th. Went down for a few weeks, then we're making this product for a little while. When it started back up at the week of August 6th, looks like there was a lot of issues with performance, which caused your TEP and OEE calculations to look terrible at basically less than 50%. Tons of room for improvement. You would have technicians going out looking at the machine, see what's going on there. Maybe it's some quality factors with the product you're building, or the parts you're putting into the machines. Could be a variety of things, but these are things you would want to look at and go out and improve to get your better efficiency on your machines. Let's go ahead and take a look at the operations dashboard. The operation dashboard here provides a real-time view of production lines, the status, allows your managers to look at the data and quickly troubleshoot problems in real time. This screen is a customizable, resizable widgets. There's a 6x6 panel, and there are about 24 widgets that you can select from. Just drag and drop into place, and then you stretch the widget to however prominent you'd like to see them. This gives you the ability to monitor OEE and or current manufacturing line performance. Screens like this OEE example are great to have on large monitors on a manufacturing floor. You see that a lot. You can also build dashboards for things like product and process yields, throughput cycle time. These kind of dashboards are kind of a front office display you can have, and be good for managers, planners, and your quality department especially to see this kind of data at a glance. There's also many other widgets configurable that you can select for different data points. And within each of these widgets that you put in, there's also filters that you can further refine what you want to see. Yields by a specific process, or filter by specific parts. There's probably 24 or so different widgets you can select from. Next screen is it's actually a favorite of mine. It's the 42Q live screen. This screen allows you to see in real time the status of all the critical stations on your manufacturing floor. yield, throughput, overall equipment effectiveness, and machine layers give you a full picture of how your floor is running. And there's also alerts and notifications that can be sent out based on how you have your metrics set up for threshold settings. So this particular screenshot shows a work center that's got a few assets that are being monitored for OEE. You aren't limited to just this one screen. If you have several work centers or production floors, you'd create separate layers for each of those. And depending on the type of layer, the cards at the bottom will change. In this case, you're seeing an OEE layer. So you're seeing corresponding OEE cards, which you're showing your OEE, your TEP, and the individual components of OEE. If you're building like a machine layer, you'd see other cards that would represent the shop orders at the different workstations. Now, if you remember the operator I mentioned that had turned down the speed of his machine, yeah, this was a screen that made it real evident. There was a not so nice yellow dot that showed up on the screen, and there was also a dip in the performance, indicating that there was a problem. So the plant manager actually walked over to see what was going on, found that he had turned down the machine speed and said, what are you doing? And the operator explained what he's doing, and nothing bad happened to the operator. The manager showed him a tablet, hey, this is what's going on. I can see you've got this performance thing here, it's yellow. And he explained to him how turning down that speed affected everything else. So again, really good, real-time information that can go ahead and improve your efficiency of all of your assets and stuff. So with that, I'll turn it back over to you, Bobby.
All right, thanks, Jim. So to do a real quick recap of everything that we've gone over. So the first thing is overall equipment effectiveness, OEE. This is going to give you a single metric to identify how productive your manufacturing facility currently is, again, at your current operating schedule. Total effective equipment performance, or TEP, that's going to give you a single metric to identify how much unlocked capacity you have at your facility. So how much more room do we have that we can grow within our current setup? And then number 3 is 42Q is going to give you a single location where you can gather all this information needed for your OEE and TEP calculations. And then in 42Q, you're going to have access to reports and dashboards on the real-time OEE and TEP statistics. You're going to be able to pull those up really quickly and easily and see all that information. There we go. All right, so if you want to find out more about using OEE or just more about 42Q in general, you can contact Wellington Giolo. He's our Senior Director of Business Development and Strategic Alliances. So his contact information is right here. Also, we're going to be sending out a follow-up email in the next couple of days. And in that, we'll have
So thank everyone for attending this
PDF
webinar, and we
of
look
these
forward to
slides.
seeing you on the next 42Q
And we'll let you
webinar.
know if anybody
Everyone
wants
have a
to
good day.
watch a recording of this, how you can get access to a recording of this webinar as well.